Hi, my honors super chemist out in King William County. I'm here to talk to you today about density and percent error. So if you look at your math unit notes that are posted on Schoology, I'm towards the end of them looking at density. And all of you guys already know the formula for density because your middle school teachers taught it to you. And the one thing I showed you in class that you may not have seen before was the density pyramid. And the density pyramid looks like this. And my high school teacher taught me this, and it got me through college, it got me through graduate school. It will get you through any density problem you ever encounter in your life. So, here's the density pyramid, and I remember it this way. Where do you go to get your driver's license? You go to the DMV. DMV. And this right here gives me all of the formulas for density. For instance, density equals mass over volume. If I'm solving for mass, mass is density times volume. And if I'm solving for volume, volume is mass over density. Okay? That's every density problem you'll ever need to know. So we're going to look at a couple of the examples. I'm only going to do the first two on this page because density is super easy for smart kids like you. Okay? If you look at the first example, you have seawater. And again, these notes are on Schoology, and we did them in class. And I gave you density, I gave you mass in the first example for seawater. I wanted you to solve for volume. Well, volume is mass over density. So the first thing I would do is write my formula down, and then I would start plugging in my numbers. So the mass of the seawater was 52.6 grams. And that was given to you. And the density of the seawater was given to you as well. And you can all plug and chug this into your calculator. Super easy. You end up with 51.3. I would like to see some units after that. Volume is always going to be in milliliters, or you can say grams and grams cancel, milliliters kicks up. There you go. If what I just did with the units gives you the heebie-jeebies right now, volumes in milliliters, it's going to be in whatever this unit is right here, whatever volume the density is in. I'm going to go ahead and do the second example with you, and then we're going to call it quits on density and talk about one other thing. The second example involves diamond, and I gave you the mass and the volume, and I asked you to find density. No problema here. Density is mass over volume. Okay, you guys knew that already. And now I just plug and chug my numbers. The mass of the diamond was 2.13 grams. The density of the diamond, the volume of the diamond was 0.65 milliliters. Plug and chug in my calculator, and I end up with 3.3. Density is always going to be in grams per milliliter, grams per milliliter. And that's density in a nutshell. I should not be able to trick you on any density problem as long as you know your density pyramid. Now, the last thing I want to talk to you about is going to be percent error. Okay? Percent error is super important to a super chemist because we're going to be doing lab work, and I want to know how much error is in your lab work. And I don't want you to be afraid of having error in your lab work. You know, we use wonderful equipment here, but it is not state-of-the-art technology. We are humans. There is error in the things that we do just by human nature, okay? But we want to be able to quantify how accurate our data is, okay? And that's all percent error is. So we used our handy-dandy formula, which had these bars, which didn't bother anybody. That meant absolute value because we're all super math students as well. Absolute value means your number's just going to be positive. So percent error is what you get. It's your data from your lab. It's your number that you got. Minus what the actual number is. The number I give you that I said, well, it should have been this. You got 4 grams. It should have been 6 grams. Okay? The actual is something that I give to you. Divided by the actual. Because it is a percentage, you always do what with percentages? Multiply by 100. Okay? Shazammy poo poo, there's your formula. So all we're doing with percent error is just plugging in numbers. What we get minus the actual over the actual times 100. And if we get a negative answer, because we have these absolute value bars there, we're always going to make it positive. Okay, guys? Well, I hope that helps you out some. I hope you're doing well at home when you're watching this, and I can't wait to see you back in class again, Super Honors Chemist. Toodles poodles, bye.